Hi, and welcome to another video on object-oriented programming in C#, with me, Marinus Toman. Okay, so in this video we're going to cover comments, variables, data types, and typecasting. So we start with some comments in C#. So if you've used Java before, you'll be familiar with these. So single line comments start with 2 forward slashes, and any text between the forward slash and the end of the line is ignored and will not be executed. So this is the first example, and because anything after the 2 slashes till the end of the line is ignored, this example is okay as well. And multi-line comments are the same as Java as well, so it's a forward slash and a star to open, and ends with a star and a forward slash. So whichever you want to use yourself is it's up to you, and again, you can follow this code and guide. Okay, so comments are pretty straightforward, and it's always good to comment your code with descriptive comments, especially when you're working in a group or with a team of developers. Okay, so looking at the variables now in C#, we have a few common types that you're probably familiar with. Int, double, character, string, and boolean. So integers store whole numbers without decimals, doubles store floating points with decimals, character stores single characters surrounded by single quotes, and strings store strings of characters that are surrounded by double quotes, and booleans store either just true or false. So the general syntax for declaring a variable is, first we need to say which type it is, so one of these types, and then give it a variable name. So this is typically the naming convention. Start with a small letter and use camel notation, and then equals whatever the value is that you're assigning. So in this example here, we could create a string called name, and that's equal to John, and then we just output that to the console. Another example is an int. You could just int mynum equals 15, and we could go on and on with all different types here. So double, you could just have a decimal point, and you can end with d to state that it's a double instead of a float. Character is single quotes. Boolean is just true or false, and string is a string of characters in double quotes. So variables, variable types are pretty straightforward, pretty much the exact same as Java. So looking at constant variables, so sometimes you have variables that you don't want to change the value, and in this case we use the const keyword in front of the variable type. So this example here, this is a constant integer called mynum, and it's equal to 15. So if we try to change the value of mynum later on, this will actually give us an error. So this constant keyword's useful when you want a variable that always stays the same. An example could be pi, or the speed of light is a constant, for example. So once a constant is declared as well, it has to be initialized with a value. So if you don't initialize a constant as soon as you're on the same line that you're initializing it, then it'll give you an error as well. So if we want to display our variables, as we've seen before, it's just console.writeLine, and then we can use this plus symbol here to to concatenate our strings inside the right line brackets. So another example here could be John with a space for first name, Doe as last name, and then the full name would be first name plus last name, so that's just concatenating the strings, and then we could print the full name out, and that would just show John Doe. So for numeric values, this would just print the answer of the sum of x and y, which would be 11, and doubles are the same as well. Okay, so sometimes for testing purposes you might want to print the value of your variables out to the console, just for debugging purposes. So that's useful for us to know. Looking at multiple variables, so we can declare multiple variables of the same type on the same line. So in this example we've got 3 integers, and then we're just print them out to line out to the console as usual. We could also do this. We could initialize them on one line, and then we could assign a value to them on another line, and in this case x, y and z will each get assigned the value 50, and then the output here will be 150. So just as kind of a convention, variables, they have to be identified with unique names, so that's a requirement of the language, and these are called identifiers. So as you can see here, there's some good conventions. So a variable name that's descriptive is always good, and so when you come back to the code again, it's actually understandable when you're reading the code. So in this example you can see minutes per hour is equal to 60, but this int m equals 60 would actually compile and it'd be okay, but if you come back to look at this code again, it would be pretty hard to understand what m stands for. So it's always better to have more descriptive variable names. And then we have some general rules for naming variables, so they can contain letters, digits and the underscore letter, but they must begin with a letter. And names should start with a lowercase letter and cannot contain white space, so no space at all in the names. Names are case sensitive, so myvar with a capital V and myvar with a lowercase v are different variables. And then reserved keywords like C# keywords such as int or double cannot be used as names, so that's just standard enough, same as every other programming language. You can't use keywords as your variable names. Okay, so that's variables. We'll move on now to data types. So as we can see here, we've got many different data types in C#, pretty much the same as Java and C++. So an integer stores whole numbers from -2 billion to +2 billion. Long, it stores larger numbers, so it stores 8 bytes, and this for really long numbers. The float stores fractional numbers, so this is okay for storing 6 to 7 decimal digits. And then a double stores fractional numbers as well, but like the long is to the int, the double is double the size of the float, so that's where it gets its name from. A bool is just 1 bit, it's either true or false, it's either a 1 or a 0. A character stores a character or a letter surrounded by single quotes, so that's 2 bytes. And then a string can have it's usually 2 bytes per character, so store sequence of characters. Numbers are divided into 2 groups, so we've got integers, so these are whole numbers that are positive or negative without decimals, and then we've got floating point, or as we call them, doubles, so they contain 1 or more decimal points. So even though there are many numeric types in C#, the most used for numbers are int for whole numbers and double for floating point. However, they'll be described down here. So as we say, it's from int stores numbers from about -2 billion to +2 billion. So this will be an example of that. And then when we get to really large numbers, we put an L at the end to denote that it's long. An F at the end with decimal point is a float, and then D at the end with decimal point is a double. So when choosing to use a float or double, the precision of a floating point value indicates how many digits the value can have after the decimal point. So the precision of the float is only about 6 or 7, while the double has a precision of about 15. So most of the time we'll just use double for most calculations, because we don't really, we don't care too much about these memory requirements, because they're pretty small in today's terms. So scientific numbers, they are denoted with an E to indicate to the power of 10. So this example here is 35 by 10 to the power 3. This is 12 by 10 to the power 4. Booleans are just simple enough. They're either true or false. It can only be 2 values. Character is just a single character with single quotes, and then, as I said before, strings are just a sequence of characters. Okay, so moving on finally to typecasting. So typecasting is when you assign a value of one data type to another data type. So in C# there are basically 2 types of casting. So we have implicit casting. This happens automatically at whenever your program is compiled. So this converts a smaller type to a larger type. So if we were going from a smaller type, like a character, which is 2 bytes, into an integer, which is 4, or if we were going from an integer, which is 4, into a long, which is 8, and so on, this could just happen automatically. But when we talk about explicit casting, so this has to be done manually, because what we're doing here is we're converting a larger data type into a smaller data type. So for example, if we were going from a double to a float, a double is twice the size of a float. So what you're basically doing here when you're explicit casting is you're truncating the last, in this instance it would be maybe the last 10 decimal places, and so on. If it was a long into an int, then if this was a really long number, then it would be chopped right down to only the size that the integer could actually fit into memory. Okay, so when we're doing the implicit casting is automatically done for us, because there's no problem there. We've got plenty of room when we're going from small into big. But when we're going from big into small, we basically have to do explicit casting, because we need to truncate the data. So implicit casting is just, like we said, it's just automatically done. So I've got a double here, and I'm trying to store an integer into it, and a double is a lot larger than an integer, so that's no problem. But with the explicit casting, if we went the other way around, if we tried to have a double equal assigned to an integer, then it's going to be way too big. So the way we get around this, and the way we do explicit casting, is we just put the type in brackets in front of the value that we want to cast. Okay, so my double, this 9.78, is going to be cast into an int, and basically what happens is, because an integer doesn't have any decimal points, it's just going to chop off anything after the decimal point. So as we see here, my int will just output 9, because everything else gets truncated. There are some type conversion methods, especially for strings. You'll be using these a lot, but you can see here we can convert my int to string. we can convert an int to a double, convert a double to an int, or a boolean to string. So many times there's no need for type conversion, but sometimes you have to. And this is especially important when we look at user input. But for now, that'll finish us on comments, variables, data types, and typecasting. Okay, so that's everything for the video. Thanks for watching.